Hi students, this is Sivakumar, 12th standard Business Mathematics and Statistics, chapter number 4. Now, exercise 4.5. Second order, first degree differential equations with constant coefficients. Look at the general form. It's a differential equation. Order of the differential equation you know very well, already have been taught. dy by dx, that's the first order. D squared by dx squared, that is the second order. We have to consider the second order. Highest one is the second order. The whole power is 1. So order 2, degree 1. So second order, first degree differential equation. Here you can consider d by dx as capital D, d squared y by dx squared as capital D squared. So this equation can be written as a into capital D squared into y plus b into d by dx is capital D, therefore capital D into y plus cy that is equal to f of x. Here y, here y, here y, you can take y as common. So you will be getting a d squared plus bd plus c. That can be written as psi of d, or you can say pi of d. What it is? Pi, phi, pi of d. That is equal to function of x. Right hand side, it's a function of x. Okay, where a, b, and c are constants. Now, here in this part we have the final solution y that is equal to cf plus pi. Cf refers complementary function and pi refers a particular integral. Look at the particular integral that is equal to 1 by psi of d into f of x, right? Then how to find the complementary function? Here it is. The quadratic equation, if you solve the quadratic equation, you will be getting 3 different types of roots. If you solve, the roots may be real and distinct. In that case, you can write the complementary function as a into e power m1x plus b into e power m2x. Suppose the roots are real and equal, the complementary function is ax plus b into e power mx. Suppose if the roots are imaginary, complex roots, if it is of the form alpha plus or minus a beta, the complementary function is e power alpha x into a cos beta x plus b sin beta x, where a and b are arbitrary constants. Then, important note here, particular integral already told you 1 by psi of d into e power ax. Replace d by a. A is the coefficient of x, provided that psi of d, or you can consider pi of d, already told you, that is not equal to 0, where d is equal to a. Then second one, if psi of d is equal to 0 when d is equal to a, then have to consider the particular integral as x into 1 by psi dash of d into e power ax. Replace d by a, provided psi dash of d is not equal to 0 when d that is equal to a. Then third one, if psi dash of d is equal to 0 when d is equal to a, then we have to consider the particular integral as x square into 1 by psi double dash of d into e power ax, and so on. It is going on. Okay, this is an introduction. While working out the problem, you can understand the concept very well. Then we can get into the exercise. Exercise 4.5. Problem number 1. Question is solve only. D squared y by dx square minus 6 into dy by dx plus 8y equals 0. Okay. Listen carefully. D squared divided by dx squared, that is capital D squared, already I told you, into y minus 6. D by dx, that can be replaced by capital D into y as it is, plus 8y, that is equal to 0. Here you can take y as common. If you take y as common, this is a d squared minus 6d plus 8, that is equal to 0. Once you change the given differential equation into this form in terms of d, this is called pi of d, or even you can say psi of d. This expression in terms of psi of d or pi of d. Okay. Now we have to find out that complementary function before finding that. We have to find out the auxiliary equation before finding the complementary function. So auxiliary equation. How to frame the auxiliary equation? Listen carefully. Here, the expression which is inside the brackets, what it is? D square minus 6d plus 8. That d, capital D, has to be replaced by m. For your reference, I write here, replace d by m. Okay. So you'll be getting m square minus 6m plus 8. Since it is an equation, you have to write that is equal to 0. Again I tell you, I consider this expression, particularly this expression which is inside the brackets only, replace a d by m. So you'll be getting m squared minus 6m plus 8. Consider this only is equal to 0. Whether any number or any expression in the right hand side, no need to bother. Here you have to consider only 0 in the right hand side. This one has to be factorized. You have to find out the values of m. It is a quadratic equation. Definitely this equation has two roots. How to find? 1 into 8, that is equal to 8, and the coefficient of m, that is equal to minus 6. Product 8 sum minus 6. The two numbers are, for getting 8 ones are 8, we have 4 twos are 8. So you have to consider 4 and 2 only, then only you can get 6. For getting minus 6, I have to introduce minus for both the numbers. Minus 4 minus 2, that is equal to minus 6. Multiply the two numbers, minus into minus, plus 4 twos are 8. Now, for finding the factors, we need two linear factors. Have to consider the coefficient of m square. What is here? 1. Write 1 in the numerator, put the variable m. 1 into m, because this equation in terms of m. Now 1 into m minus 4. That is the first linear factor. Next one, 1 into m minus 2. Okay. If you multiply these two, you will be getting this expression. So m minus 4 into m minus 2 equals 0 means m minus 4 equals 0 or m minus 2 equal to 0. Correct? Which implies m, that is equal to 4, and minus 4 comes right hand side, plus 4, minus 2 comes right hand side, plus 2. So we have two different values of m. So you have to consider m1 equals 4 and m2 equals 2. Since they are different, I consider them as m1 and m2. Now the roots are real numbers, 4 and 2 are real numbers, and distinct. Distinct means different. In that case, already we discussed how to write the complementary function. Complementary function equals a into e power m1x plus b into e power m2x. Because the x, why I have written x? No, here what is in the denominator? X is a function, correct? X square, an x function, here x function, so that you have to write x. That is equal to a into e power m1. This m1 can be replaced by 4x plus b into e power m2 that is equal to 2x. Even you can consider m1 as 2, m2 that is equal to 4. Okay. So complementary function is over. Then you have to find out the particular integral. Particular integral, I already told you, 1 divided by psi of d or pi of d. That means this expression. This is pi of d. Into the expression which is in the right hand side. What is in the right hand side? 0. Correct? So I write over here 1 divided by d squared minus 6d plus 8 into what is here? 0. You just write the 0 only. If it is 0, 0 into anything is 0 only, you can straight away write that is 0. So whenever 0 in the right hand side, you can straight away write particular integral equals 0. This is all not necessary. You can straight away write pi equals 0. Finally write the solution. Solution y that is equal to, which one is common here? Y. So that y equals CF plus pi equals CF, here it is what it is, a into e power 4x plus b into e power 2x plus particular integral value 0. So which implies what is in the left hand side? Y equals a into e power 4x plus b into e power 2x. So problem number 1 is over. I'll be teaching that next problem in the next video. Thank you, children.